Welcome to the Joy of Architecture. You're joining us for another deep dive. We've got a big stack of research here on a really fascinating architectural style, and we're going to distill it all down for you. Today, we're unpacking microfrontend architecture. It's seriously changing how large web applications get built. If you've ever wondered how these huge companies manage their massive websites without, everything grinding to a halt, well, you're in the right place.
Yeah, it's pretty fascinating. What's really key here is how microfrontends basically take a concept we know well from the backend microservices and apply it directly to the UI. It's all about breaking down those giant kind of unwieldy front-end monoliths into smaller chunks that teams can manage independently.
Right. So our mission today, we're going to walk through the definition, the why, the how, and even look a bit into the future of microfrontends. The goal is you walk away really understanding this stuff.
Okay, let's dive in. Let's start right at the basics. What exactly is a microfrontend? Martin Fowler, who's, a big name in software architecture, he defines it as an architectural style where independently deliverable front-end applications are composed into a greater whole.
Right. So think about it like this. It's not the entire web page. It's a specific piece, maybe like the search bar or the shopping cart or one widget on a dashboard. Each piece is built and deployed on its own. Then there's usually a main sort of app shell that pulls these pieces together for the user.
And this idea really started getting traction, around late 2016? It came about because those single-page apps, SPAs, they were just getting too big, right? Turning into these front-end monoliths.
Exactly. You had these crazy long build times. Coordinating changes was a nightmare. Bottlenecks everywhere. Teams were getting stuck. And companies like Zalando, IKEA, Spotify, they were already running into these problems, kind of pioneering solutions even before the term was common.
Yeah, and you can really see the connection to microservices. It's that same thinking. Break down the big back-end monolith. Okay, now let's do the same for the front end. We went from, old school full stack monoliths, then we separated front end and back end with SPAs, talking to APIs, but that front end often stayed this big single block.
So the back end got agile, but the front end became the bottleneck.
Pretty much. Microfrontends try to fix that with what's called vertical slicing. A single team owns a feature from the database all the way up to the pixels on the screen. End-to-end ownership.
That vertical slicing feels really key. So compared to a traditional front-end monolith, what are the big differences? You mentioned deployment earlier.
Deployment is the game changer, honestly. With the monolith, even a tiny change means you rebuild and redeploy the whole thing. Risky, slow. Microfrontends. Each piece has its own deployment pipeline. You change the search feature. You only deploy the search microfrontend. Faster releases, much lower risk.
Okay, so independent deployment. That must impact how teams are set up too.
Absolutely. It enables smaller, autonomous, cross-functional teams. Instead of one huge front-end team stepping on each other's toes, you have focused teams owning their slice. Less coordination chaos.
And tech choices. Are you stuck with one framework?
Nope. That's another big plus. Technology agnosticism. One team might use React for a really dynamic part. Another might use Vue for a simpler form. They choose the best tool for their job.
Interesting. And scalability. How does that compare?
Well, you scale a monolith by just running more copies of the whole app. Microfrontends help more with organizational scaling. Lots of teams can work in parallel without blocking each other. And it improves resilience, too. If one microfrontend breaks, it hopefully doesn't crash the entire UI.
Okay, so it sounds like this is really driven by the need to scale the organization, maybe even more than the tech itself.
That's a really sharp insight. I think that's often the primary driver. It solves the people coordination problem as much as the code problem. But you mentioned something important earlier.
The user experience. If every team is doing its own thing, how do you keep it consistent?
Yes. The classic tension, autonomy versus consistency. The answer, almost always, is a robust, centrally managed design system. Think shared component libraries, buttons, forms, styles, and clear guidelines. That provides the guardrails so the user still gets a unified experience, even with all that underlying independence.
Makes sense. So, okay, why take on all this complexity? What are the big drivers pushing organizations towards this?
Number one, hands down, is scaling development across large organizations. Like we said, add too many devs to a monolith and productivity grinds down. Merge conflicts, communication overhead. It's painful. Microfrontends let teams work in parallel more effectively.
And you mentioned tech stacks earlier?
Right. Driver number two, handling diverse tech stacks and, crucially, incremental modernization. You've got a massive legacy system. You can't just rewrite it all at once. Microfrontends let you use that strangler fig pattern. You build new features as microfrontends with modern tech, maybe React or Vue, and gradually chip away at the old monolith, replacing bits over time. It's a practical path forward.
That sounds much less daunting than a big bang rewrite. And what about just huge code bases, millions of lines of JavaScript?
Yeah, that's the third driver. Managing sheer scale. Breaking a massive front end into smaller domain-focused chunks just makes it more manageable. Easier to understand, easier to test, faster builds, reduces the cognitive load on developers.
Okay, so it's powerful, but when is it actually the right call and when should you maybe hold back?
Ideal scenarios. Large, complex applications where you can naturally carve out distinct business domains. Think e-commerce.search is different from checkout, which is different from product display. And critically, when you have multiple teams, maybe 3 or more, or say 15 plus developers who genuinely need to release features independently, that independent deployment need is key. Also great for that legacy modernization we talked about.
And when should you be cautious?
Definitely avoid it for small projects or small teams. The overhead just isn't worth it. A well-structured monolith, maybe modular, is way better. And crucially, it's not a silver bullet for fixing bad code or technical debt. If you just slice up a messy monolith, you'll likely end up with a distributed monolith. All the complexity, none of the benefits.
Ouch. The distributed monolith. Sounds bad.
It is. And you absolutely need a mature DevOps culture. Robust CI/CD, infrastructure as code, solid monitoring, automated testing. If your operations aren't ready, the complexity will just swamp you.
So it doesn't eliminate complexity, it just moves it around.
Exactly. You trade internal code-based complexity for external operational and integration complexity. It's a conscious trade-off. And that has security implications too, doesn't it?
Right. You mentioned the increased attack surface.
Yeah. More moving parts, more deployed things, diverse technologies. It means more potential vulnerabilities. You absolutely need a zero-trust mindset where you don't implicitly trust communication between components. Everything needs to be verified.
Okay, so lots to consider. Let's get into the how. How do you actually bring these independent pieces together for the user? What are the integration techniques?
Broadly, there are two main camps. First is build-time integration. Here, your microfrontends are basically published as libraries, like NPM packages. A central container app installs them as dependencies and bundles everything together into one big JavaScript file for deployment.
So simpler setup, maybe, but doesn't that break the independent deployment goal? If you change one piece, you still have to rebuild and redeploy the whole container.
Precisely. That's the major downside. It kind of defeats a core purpose of microfrontends. So while it exists, it's less common for true microfrontend architectures.
Okay, so what's the alternative?
That's runtime integration. This is where the magic usually happens. Each microfrontend is deployed completely independently. Then, in the user's browser, the container application dynamically fetches and renders the needed microfrontends on the fly.
Ah, so that enables true independent deployment and tech flexibility. What are the catches?
Well, it's definitely more complex to set up. You can have performance hits from loading multiple scripts over the network. And there's the risk of runtime conflicts, like two microfrontends trying to use different incompatible versions of React on the same page.
Right, the dreaded dependency conflicts. So within runtime integration, how do you actually compose the UI?
Several ways. An older, but sometimes still useful technique is using iFrames. Each microfrontend runs in its own little sandboxed window within the main page. Spotify famously used this.
iFrames. They get a bad rap sometimes. Strong isolation, though.
Strongest isolation, definitely. Sandbox DOM, CSS, JavaScript, great for integrating really different or legacy apps. But yeah, downsides include performance issues, SEO challenges, making them responsive can be tricky, and communication between them is clunky using window.postMessage.
Okay, so what's more modern?
Web components are a big one. These are browser-native standards for creating reusable, encapsulated UI pieces. Think custom HTML tags like product card or search widget. They use things like the shadow DOM to encapsulate their styles and structure, preventing CSS conflicts. Because they're browser standards, they're framework agnostic. React, Angular, Vue. They can all use or be wrapped in web components.
Standards-based, framework agnostic. Sounds good. Any weaknesses?
Some minor CSS things can still leak globally if you're not careful, and you might need polyfills for older browsers, though that's becoming less of an issue.
Got it. What else is common?
A lot of approaches use JavaScript-based orchestration. This often involves a top-level router or shell that dynamically loads and manages the microfrontends. Two big players here are Single SPA, which is a meta framework designed to help multiple frameworks coexist on the same page, managing their life cycles. And then there's Module Federation, which is a feature of Webpack 5.
Module federation, that one comes up a lot. What's the key thing there?
Its killer feature is allowing separate applications, built and deployed independently, to dynamically load code from each other at runtime. And crucially, it's smart about sharing dependencies. If multiple microfrontends need React, module federation can ensure only one copy is actually loaded in the browser. Huge performance win.
That is clever. It really tackles that dependency duplication problem.
Exactly. Then there are also server-side or edge-side approaches, like server-side includes, SSI, or edge-side includes, ESI, where HTML fragments are stitched together on the server or at the CDN edge before hitting the browser. IKEA used ESI, for example. Good for SEO and initial load performance on content-heavy sites.
Wow, okay. So many options. It really highlights what you said earlier. The choice of composition technique really shapes the whole system and its trade-offs. iFrames give isolation but pain points elsewhere. Module federation fixes dependency sharing but ties you to Webpack.
Precisely. There's no single best way. It's about picking the pattern whose constraints and complexities your organization is best equipped to handle.
And once you have these pieces on the page, how do they talk to each other? If the search microfrontend needs to tell the cart microfrontend something happened.
Communication. The golden rule here is aim for loose coupling. Minimize direct dependencies. Avoid one microfrontend directly calling functions in another if you can help it. Think asynchronous.
Okay, so no direct calls. What then?
The most recommended pattern is using browser custom events. It's like a publish-subscribe system built into the browser. One microfrontend dispatches an event, new custom event, product added detail, and any other interested microfrontends can listen for it. It's decoupled and uses native features. Some teams use a shared event bus library, which is a similar pub/sub idea but implemented in JavaScript.
What about sharing state, like using Redux or something similar across microfrontends?
You can, but tread very, very carefully. Sharing a global state store like Redux across multiple independent microfrontends can easily turn into a shared state monolith. It reintroduces coupling and can become a huge bottleneck. Use it with extreme caution, only for truly global state.
Got it. Loose coupling, custom events preferably. Avoid shared state unless absolutely necessary. Okay, let's shift to tooling. We've mentioned some names, but what are the key frameworks and tools that architects actually use to build these?
Right, so we touched on single SPA, that meta framework for orchestrating different frameworks. We talked about module federation, which is specifically a Webpack 5 plugin for dynamic code loading and dependency sharing. There's also Pyrrole, which is more of a batteries-included framework for building portal-like applications with microfrontends they call pilots. It comes with a CLI and a whole ecosystem.
And SAP has one too, right?
That's Luigi.
Yes, Luigi. It's SAP's open source framework, aimed at creating consistent enterprise UIs. It provides a core shell and client libraries to handle routing, navigation, permissions, often using iFrames or web components under the hood. Very focused on consistency in large organizations.
What about Zalando? They were pioneers.
Zalando's journey is interesting. They started with Project Mosaic, which used server-side composition. They've evolved that significantly into a more sophisticated platform, often involving GraphQL for data fetching and composing entities via renderers. It's quite advanced.
Okay, so a range of tools from basic orchestrators to full platforms. What about the build and deployment side? You said independent CI/CD is crucial. Absolutely non-negotiable. Each microfrontend must have its own automated build, test, and deploy pipeline. That's fundamental.
And versioning. How do you manage updates?
Two main approaches. One is evergreen. The container app just always pulls the latest available version of each microfrontend. Simple, but risky if a bad version gets deployed. The other is managed. The container specifies the exact version of each microfrontend it needs. For example, search widget at 2.1.3. This gives stability and control over rollouts, but requires more governance to manage all those specific versions. Semantic versioning, semver, is key here.
And that shared dependency issue keeps coming up. Module federation helps, but how else do teams manage it, especially if they don't use Webpack 5?
It's tough. The dilemma is always duplicate dependencies in each bundle, safer isolation, bigger apps, or try to share them. Better performance, risk of version conflicts. If you're not using module federation, you might rely on things like browser import maps, though support is still evolving, externalizing common libraries via script tags, the old way, or very careful coordination, often within a monorepo.
The monorepo. Interesting. You'd think separate repos for separate deployments, but you're saying a monorepo might actually be better for development.
Often, yes, for the developer experience. A monorepo, maybe managed with tools like Lerna or Nex, makes it much easier to manage shared dependencies enforce consistent versions, run tests across affected projects, and share tooling. You can still set up independent deployment pipelines from within the monorepo for each microfrontend. It gives you coordinated development with independent deployment.
That's a really interesting point. Okay, let's talk cross-cutting concerns, the stuff that touches everything. Authentication, consistency, performance.
Yeah, these are critical. For authentication and authorization, best practice is usually centralized auth. The user logs in once. Token-based patterns like OAuth 2.0 with GWTs are common. But how do you securely share that token or session across different microfrontends, potentially on different domains?
Good question. You don't want JavaScript just passing tokens around loosely.
Definitely not. A very secure and recommended pattern is the backend for frontend, BFF, or sometimes called the token handler pattern. The idea is the client-side JavaScript never directly sees or handles the sensitive access tokens, like JWTs. Instead, the user logs in, the authentication server talks to a dedicated BFS service, the BFF sets a secure HTTP-only session cookie with the browser. Then, when a microfrontend needs data, it makes a request to its BFF, or a shared API gateway acting as one. The BFF validates the session cookie, securely retrieves the necessary token on the backend, attaches it to the downstream API call, and returns the data. The token lives server-side.
Okay, so the BFF abstracts away the token complexity from the front-end code. Makes sense. What about keeping the look and feel consistent? We mentioned design systems.
Crucial. A centralized design system is the single source of truth for UI/UX. It includes style guides, design principles, and importantly, a library of reusable shared UI components, buttons, inputs, cards, etc., that all teams consume as a dependency. Tools like Storybook are great for developing and documenting these.
And preventing styles from clashing.
Style encapsulation is key. Shadow DOM in web components is great for this. Otherwise, techniques like CSS modules, CSS and JS, or even strict naming conventions like BEM are needed to scope styles and prevent leakage.
Performance always matters. What are the big levers here?
Bundle size is a major one, especially if you're duplicating dependencies. That's why module federation or careful dependency management is so important. Lazy loading is absolutely critical. You should only load the code for a microfrontend when the user actually needs it, like when they navigate to that part of the app. Don't load everything up front.
Right, and caching.
Yes, standard web performance stuff applies. Serve static assets from a CDN. Use techniques like cache busting, putting a content hash in file names so you can tell browsers to cache assets aggressively for a long time.
Testing sounds like it gets more complicated too.
It does. You still have your unit tests for individual functions and components in isolation within each microfrontend. You also have component or integration tests that verify pieces within a single microfrontend work together. But the really vital addition is contract testing. Since these things are deployed independently, you need a way to ensure they still understand each other's APIs or event structures. Contract tests, using tools like Pact, define these expectations. I expect the user service to give me an email in this format. They run quickly in CI and catch breaking changes between services without needing slow, full, end-to-end tests for everything.
So contract tests check the boundaries, but you still need full system tests sometimes.
Yes, end-to-end E2E testing is still essential to validate complete user journeys across multiple microfrontends, simulating a user adding an item to the cart, going through checkout, etc. They can be brittle and slow, but necessary for confidence. Tools like Cypress or Playwright are common here.
And when things go wrong, how do you figure out where the problem is in this distributed mess?
That's where observability comes in. It's more than just monitoring. It's understanding the system's internal state from its external outputs. 3 pillars. Logging. Each microfrontend and service needs to output structured logs, preferably aggregated into a central system like Elasticsearch or Splunk. Metrics. Tracking key numerical data over time, page load times, API error rates, transaction counts, tools like Prometheus for collection, Grafana for visualization. And the really critical one for distributed systems, distributed tracing. When a request comes in, it gets assigned a unique trace ID. This ID is passed along through every microfrontend, every API call involved in handling that request. Tools like Jaeger or OpenTelemetry can then reconstruct the entire journey of that request across all the different services, showing you exactly where delays or errors occurred. It's indispensable for debugging.
Wow. Logging, metrics, and especially tracing seem non-negotiable. It sounds like getting these cross-cutting concerns right requires dedicated effort.
Absolutely. And this often points to the need for a dedicated platform team. It's just not efficient or realistic for every single product team to build their own CI/CD pipeline templates, authentication solutions, observability stacks, and manage the design system infrastructure. Successful microfrontend setups often have this two-tiered structure. Product teams focused on building business features, and a platform team focused on providing the shared infrastructure, tools, and capabilities that enable the product teams to move quickly and safely.
That platform team concept makes a lot of sense. Okay, let's look at some real-world examples. You mentioned Spotify using iFrames.
Right. Spotify's desktop app used iFrames for strong isolation between major sections like the player, search, playlists. They used a custom event bus for communication between them. It shows that even older tech can be effective if isolation is your absolute top priority.
What about IKEA? You said ESI.
Yeah, IKEA used Edge Site Includes, ESI, for their e-commerce site rebuild. Different teams owned different fragments of the page, composed of the CDN edge, great for their content-heavy, SEO-sensitive site. Their big learning was investing heavily in their design system early on was crucial for consistency during the migration.
And Zalando keeps evolving.
Zalando's journey shows the maturity path, from Project Mosaic, server-side includes, to a much more sophisticated system using GraphQL and a declarative UI composition model. They really treat the front end as a composed system built from entities and renderers. Very advanced, highlights the value of a unified data layer and a strong design system at scale.
Any others?
DAZN, the sports streaming service. They use client-side composition but have a fascinating philosophy. They explicitly favor code duplication over creating shared libraries, in many cases. Their rationale is that shared libraries create coupling and slow down teams. They prioritize team independence and speed above the DRY, don't repeat yourself principle. It's controversial, but works for them.
Wow, deliberately duplicating code. That goes against a lot of standard advice.
It does. It shows how context matters. Their priority is independent team velocity.
And SAP built Luigi for themselves first.
Exactly. They needed a standardized way to build consistent administrative UIs across many different teams and technologies within SAP. So they built Luigi, then open sourced it. It shows the value of an opinionated framework for driving consistency in a huge, diverse organization.
So if you're migrating from a monolith, what's the typical journey?
Almost always gradual. The strangler fig pattern is the most recommended approach. You leave the existing monolith in place, but start building new features as microfrontends alongside it. You might put a proxy in front to route traffic requests for new features, go to the new microfrontends, everything else goes to the old monolith. Over time, you incrementally strangle the monolith by replacing its features with new microfrontends until eventually the monolith can be retired.
What are the common bumps in the road during migration?
High initial investment is a big one, setting up all the new infrastructure, CI/CD pipelines, etc. Defining the right boundaries between microfrontends is hard. Domain-driven design, DDD principles, can really help here. Starting small with a proof of concept, PC, is wise to test your patterns and iron out kinks. Investing in that design system early is vital to keep the UX cohesive during a long migration. And, as we keep saying, DevOps maturity is an absolute prerequisite. You need solid automation. And recognizing it's an organizational change, not just technical teams need restructuring, clear ownership needs defining.
It really sounds like the key lesson from all these cases is there's no one right way. It depends entirely on your context, your problems, your team structure, your priorities.
Exactly. Success comes from tailoring the approach to your specific constraints and goals, not just copying what someone else did.
Okay, we've sung its praises, pointed out the pitfalls. Let's really focus on the challenges and trade-offs. No architecture is a free lunch, right?
Definitely not. The biggest trade-off, as we've hinted, is complexity. You're swapping internal code-based complexity, one big tangled monolith, for external operational and architectural complexity. Lots of moving parts, pipelines, network calls, deployment coordination.
I'm debugging that distributed system.
Much, much harder. Figuring out why a request failed when it crossed 3 different microfrontends and 2 APIs requires that sophisticated observability tracing is key. Without it, you're flying blind.
And that dreaded distributed monolith?
Yeah, the worst of both worlds. You build microservices or microfrontends, but they're so tightly coupled, maybe through synchronous calls or a shared database, or that shared state monolith we mentioned, that you can't deploy them independently anyway. You get all the operational pain, none of the autonomy benefits. It happens more often than you'd think if you're not careful about boundaries and coupling. You also risk accumulating distributed technical debt, inconsistent patterns across teams, duplicated logic popping up everywhere, outdated dependencies and forgotten services. It requires ongoing effort to manage.
What about the team coordination side? Autonomy sounds great, but
it requires governance. You need agreed-upon standards for APIs, for event schemas, for how shared libraries are versioned and consumed for using the design system. Someone has to define and enforce these standards, which takes effort. often that platform team again. Communication and knowledge sharing also become harder. You risk creating islands of knowledge within each team. You need deliberate practices, good documentation, cross-team demos, maybe guilds or communities of practice to keep information flowing. And defining clear ownership for every single piece, including the shared infra, is absolutely crucial.
And getting started isn't cheap or easy.
No, there's a significant initial investment in setting up the infrastructure, the CI/CD pipelines, maybe artifact registries. There's also a steep learning curve for teams, especially if they're not used to distributed systems thinking, containerization, advanced deployment patterns. And there can be performance overhead from potential dependency duplication or multiple network requests if not managed carefully through things like code sharing, lazy loading, and caching.
Security implications, too. You mentioned the attack surface.
Right. More deployed things, more network endpoints, more pipelines.
Yeah.
Just more places for things to go wrong or be attacked. Securing communication between services, managing authentication and authorization correctly across all these boundaries is complex. Plus, with diverse tech stacks, you have a wider range of potential dependency vulnerabilities to track across many different code bases. Centralized security scanning becomes really important. It really drives the need for that zero trust model we talked about.
And browser compatibility with all these modern techniques.
Yeah, reliance on newer browser features like web components or dynamic imports might require polyfills for older browsers. Coordinating which polyfills are needed and ensuring they don't conflict or add unnecessary bloat needs a central strategy. You're looking at all these challenges, the complexity, the coordination, the governance, the investment. It really reinforces that idea. Microfrontend autonomy isn't free. The price you pay is governance. You need just enough to keep things coherent, but not so much you kill the autonomy you wanted in the first place.
That's a great summary of the tension. And you also made a point earlier about culture.
Yes. I think this architecture acts like an amplifier for your organization's existing culture and capabilities. If you have strong communication, collaboration, and solid DevOps practices, microfrontends can supercharge your teams. But if those things are weak, microfrontends will likely just expose and exacerbate those problems. It forces you to confront organizational dysfunction.
Fascinating. Okay, crystal ball time. What's next for microfrontends? How might things evolve?
Well, some emerging browser standards will likely play a bigger role. Web components, especially with custom elements v1 being widely supported now, will become even more foundational as a framework-agnostic way to build and share UI pieces natively. Import maps are another interesting standard. They provide a native browser way to control how JavaScript modules are resolved, potentially simplifying dependency management and maybe reducing the need for complex bundler configurations like module federation in some cases. Still evolving, but promising.
What about things like WebAssembly?
WebAssembly, WASM, is really exciting. It lets you run code compiled from languages like Rust, C++, Morn, go in the browser at near native speed. You can see highly performant microfrontends written in WASM for really intensive tasks. Think complex data visualizations, 3D viewers, maybe even parts of games. It offers the ultimate potential for tech agnosticism, bringing non-JavaScript ecosystems truly to the front end.
And you mentioned edge computing earlier.
Yeah, composing microfrontends at the CDN edge is a big trend, using things like Cloudflare workers or AWS Lambda at edge to assemble pages closer to the user. The benefits are potentially huge. Better SEO compared to pure client-side rendering, super fast initial load times because you're minimizing latency, ability to run personalization or A/B tests right at the edge. The future is likely a hybrid rendering model, sometimes called an islands architecture.
Islands architecture.
Yeah, the idea is you make granular choices for each component or island on the page. Maybe the main app shell is server rendered for speed. Static content might be rendered at the edge. Highly interactive dashboards could be client-side rendered microfrontends. It's about intelligent orchestration using the best rendering strategy for each piece.
So, edge composition, hybrid rendering.
Mm.
What about enterprise scale? Federated apps.
That's another interesting direction. Think federated architecture, where different business units or domains in a large enterprise operate semi-autonomously but need to interoperate. Microfrontends become the UI layer for this federation. Each unit develops its own microfrontends representing its capabilities, and these are dynamically integrated into a unified enterprise portal or shell. The central platform provides the shell, navigation, maybe federated identity management, but the features come for the federated units.
And AI. Does AI play a role here?
Potentially, yes. We could see AI-assisted UI composition. Imagine an intelligent app shell or orchestrator that dynamically decides which microfrontends to load and compose based on the user's context, past behavior, or goals, creating highly personalized experiences on the fly. Maybe even generative UI, where some interface elements are generated by AI rather than pre-built.
Yeah.
And AI tools could certainly assist architects in suggesting optimal ways to decompose a monolith or even generating boilerplate for components based on design system rules. It's further out, but the potential is there for AI to become the orchestrator.
AI as the orchestrator. Wow, that's a glimpse into a pretty different future. Okay, this has been incredibly thorough. To wrap things up, let's put microfrontends in context one last time. How do they stack up against the alternatives? Monoliths first.
Microfrontends versus monoliths. The core trade-off is simplicity versus scalability. Monoliths win on simplicity, especially for smaller projects and teams. They're easier to build initially, easier to reason about, consistency is built in. Microfrontends win on organizational scalability and independent deployment for large, complex projects with multiple teams. Development velocity might be slower initially due to setup costs, but it tends to stay more constant as the system and organization grow, whereas monolith velocity often degrades. Microfrontends also offer better fault isolation. But remember, you trade internal code-based complexity for external operational complexity.
Okay, what about comparing them to just using feature flags within a standard single-page app?
Good comparison. Microfrontends versus SPAs with feature flags. They solve different problems. Feature flags are about decoupling deployment from release stressing. You deploy the code, still as part of the monolith, but hide it behind a flag until you're ready to turn it on for users. It's great for controlled rollouts and A/B testing. Microfrontends are about decoupling development and deployment itself into independent units. An SPA with feature flags is still architecturally a monolith, one code base, one build artifact, one deployment pipeline. Feature flags don't solve the underlying organizational scaling bottleneck if multiple teams are constantly fighting over the same code base. Microfrontends are designed specifically for that team autonomy.
So they're not mutually exclusive.
Not at all. Using feature flags with each microfrontend is actually a best practice. It gives you fine-grained release control even within your independently deployable units.
Right. And finally, what about just building traditional multi-page applications, MPAs, like separate apps for search, checkout, etc.?
Microfrontends versus native MPAs. The main difference is usually the user experience goal. Microfrontend architectures typically aim for that seamless, app-like feel of an SPA, where navigation between sections happens without full-page reloads, often within a shared shell. State management can be more complex. Traditional MPAs involve full page loads between distinct sections or applications. State is often managed more on the server side for each page load. However, here's the interesting part. A collection of well-designed MPAs can be considered a form of microfrontend architecture.
How so?
If you have separate applications, EG said, search.company.com, checkout.company.com, each owned by a different team, but they share a common design system for consistency, maybe a shared header-footer component, and use centralized authentication, like SSO, you've achieved team autonomy and independent deployment. You get many of the organizational benefits without the complexity of client-side composition frameworks. It's a perfectly valid, sometimes simpler approach on the microfrontend spectrum.
So it's really a spectrum, from a modular monolith to MPAs unified by design systems to full client-side composition with single SPA or module federation.
Exactly. It's a spectrum of decomposition. And the key takeaway is probably to start simpler. Maybe begin with a well-structured modular monolith. Only move further along that spectrum towards more distributed microfrontends when the pain points, usually organizational scaling bottlenecks, become significant enough to justify the added complexity and overhead. And always be clear on the why. What problem are you actually trying to solve? Scaling teams, modernizing legacy code, faster releases, improving code organization. Using microfrontends to solve the wrong problem is probably the biggest mistake you can make.
That's excellent advice. Understand the why before you jump to the how. What a journey through microfrontend architecture. From its roots in microservices, through all the patterns, tools, challenges, real-world examples, and even looking towards an AI-driven future. It's clear this is a super powerful but definitely demanding style.
Absolutely. I think the main thing for listeners to take away is that microfrontends aren't magic. They're not right for everyone. They shine in large, complex settings with mature engineering practices, especially mature DevOps. But they fundamentally relocate complexity. They don't eliminate it. Choosing them is a big strategic decision tied directly to your organization's structure, culture, and capabilities.
So the question for you, the listener, is how much complexity are you really prepared to manage? And where do you find your architectural joy? Is it in the elegant simplicity of a well-crafted monolith or the distributed autonomous power of a micro-frontend system? Something to think about. Thank you so much for joining us on this deep dive. If you found this useful, please subscribe to Joy of Architecture for more deep dives where we unpack complex topics just like this one. Until next time.